What's new in Python 3.11? If you look at the summary release highlights, it says that Python 3.11 is up to 10 to 60% faster than Python 3.10. On average, we measured a 1.22x speed up on a standard benchmark. So you can look at this link for more details. I'll put a link there in the description. It says that there are also new features. PEP 654, exception groups, except self-type. There's a ton of new features actually. So I thought that in this video, what we're going to do is to just go through a list of them and probably count like 7 new features that I want to really just talk about and maybe show you code examples of that. So let's dive in. So I've created a few files to help me go through the demo faster, and to save you some time, I already pre-write some of these examples so that I can show you exactly what's different in terms of Python 3.11 compared to the earlier versions of Python. I've also gone ahead and installed Python 3.11. So the way I'm gonna run this demo is I'm gonna actually show you how it looks like first. So I'm gonna say python demo0.py, and this is on Python 3.8. So if I show you python -- version, it says Python 3.8.10. Then I'll show you how it looks like when I run it with Python 3.11. So same thing, Python 3.11 -- version, and you see a different version of Python, and that's how we're gonna compare and see what are the main differences between Python 3.11 compared to the earlier versions of Python. So in demo0.py, this is a really simple dictionary, just an employer in here, and then there's the names, supertype, and then there's the website, supertype.ai, there's manager, and a name, Samuel Chan, age 32, location, country, city, residence. Okay, and then I'm saying if I run this file, the name will be main, and what should I do? I should find a manager, location, city. All right, then I said if the city, meaning this, is Jakarta, then I would just print welcome to the capital of Indonesia, and I put a flag there. Else, then I would just say manager of this, live in something else, and I'll just capitalize that so that it prints out with the J being capitalized. And I want to just maybe preface it by saying that some of these changes actually they are an extension of what happened in Python 3.10. They started from Python 3.10. So Python 3.10, if you're aware, it introduces a ton of improvements into how error messages are being handled. So they give you a lot more explicit, accurate messages about what you can do to fix an error every time an error occurred, right? So the first 3 to 5 minutes is really just talking about the error messages, because it actually carries on to Python 3.11. You see that they introduce even more enhancements to how error messages are being handled. So just to show you what I mean by that. So for example, if we forget to close this quotation mark here, so we don't have that. Now if you're using any kind of modern IDE, it's gonna catch that already, but let's just pretend we didn't see it, and let's just say Python, and let's run demo0.py. So this is the old version of Python. This is Python 3.8. Okay, so this is pre-11, and I run that. It says welcome to the capital of ID. It's because we didn't save it. Now let's save it. Run that again. It says syntax error EOL while scanning string literal. What does that even mean, you know? So EOL actually means end of line, right? But it says here it's actually pretty cryptic for beginners. So Python 3.10 and later on 3.11. So let me show you what without changing anything, let me just run that, and I'm gonna put 3.11. Now it says what? It says syntax error unterminated string literal. So a little bit less cryptic. I think it's a little bit more helpful. It's saying that there is a string literal. This is a string, yes. And it's saying that it's not terminated. We haven't actually added that. So let's fix that. It even goes to show you detected at line 19, just to tell you exactly which line to fix that. And that's kind of a pattern from 3.10, and it carries over to 3.11, and it adds a ton of improvements on top of that. So is it better than just saying EOL? Arguable, but it's more exact, and it's I feel it's more descriptive and more helpful. And really quickly, if I just forget about the closing bracket, for example, let's just save that, and let's see what happens in the earlier versions of Python. It says invalid syntax if mcd equals to Jakarta. So if mcd equals to Jakarta, this is it. It's saying that the error occurred here. It's saying invalid syntax, even to the point of slightly being misleading, because it's saying that error occurred here, while really what you want is to tell you that this is where the syntax is missing. So let's take a look at 3.11. Instead of line 18, it's telling you line 16 is where the problem occurs, not line 18, but line 16. It says what? It says location, there's an opening, square bracket, and the square bracket was never closed. So if we add that, now it's happy again. So if you run that again, now it's happy. The same goes for curly bracket. If you miss out one of them, let's just remove this one, save that. And if you try and run that with the older version of Python, just prior to Python 3.10, 3.11, this is how it looks like. It says if name equals to main, invalid syntax. But hold on. This is really not where the problems occur. This is where the problem occur, right? Let's take a look at Python 3.11. It says what? It says this curly bracket was never closed. This is a lot more helpful than to tell me that, oh, if name equals to main, line 15 is where the error is. No, actually this is where the error is. So let's fix that, and now it's happy again. The same is true for comma. So for example, if you miss out one comma, and try and do that with Python just before 3.11. See what happens. It says residence equals to true, invalid syntax. What about the later version of Python? Okay, it says expression expected after dictionary key and this. It says that after dictionary key, which is this, and then there's a colon, it's telling you to fix that. So just add a comma and the error goes away. So the general theme is that in Python 3.10, it introduces a lot of this kind of enhancement in order for you to debug your code a lot faster. So another example here is that if mcd equals to Jakarta, a very common mistake for, at least for folks who are new to programming, is that you miss out one of them and you say something like, if mcd equals to Jakarta, print welcome to the capital of Indonesia. And this is a common mistake. Let's see what happens if we run it in a previous version. It says invalid syntax, syntax error, invalid syntax. What happened with the latest version? Let's run that. This is called a caret sign. The caret actually highlights the whole offending line. It tells you this whole thing is wrong. So it highlights the whole offending expression, but previously just a single caret symbol indicating just an approximate location, saying that this is somewhere in here there is an invalid syntax. But in the later version of Python's 3.10 and then 3.11, you see that invalid syntax, maybe you meant double equal sign. That's for equality comparison. Or maybe this one, the walrus operator, instead of just the equal sign, right? So you can just fix that. This become immediately a lot more helpful, a lot more contextual, give you a lot more context about where you probably want to look at, so it helps you debug your code faster. And something that I find pretty interesting is the fact that if you misspell this, for example, instead of print, you're going to have pint. And let's run that. In Python 3. In the older versions of Python, it's just going to say pin is not defined, doesn't know what to do, right? But let's see what happens. The later version of Python, it actually says name pine is not defined. Did you mean print? So it's pretty smart, right? It's trying to guess that maybe this is what you mean. And this actually also works for things that we define. For example, mcd, I have mcd, this is it. But if I miss out one of them, and let's just take away the p just for good measure, and let's run that. And if I run it in the previous version of Python, let's see what happened. Say mcd is not defined. Cool. It's fair enough. It's straightforward. But if you run 3.11, it says mcd is not defined. Did you mean emp_cd? Well, that's the correct one. So it's making good suggestions now. You can fix that. And I spent some time talking about these differences because in 3.11, this become even better. So for example, if I miss out, let's change cd over to something like district, right? And if you run that now, let's see what happened. In the older versions of Python, let's see that this is prior, let's say this is Python 3.10, right? Not even 3.11, 3.10, you run that, it says KeyError district, but if you run 3.11, so Python 3.11, if you run that, it now, using the caret sign again, it tells you that this is where it goes wrong. So this is all still fine, and this is where it goes wrong, again the caret sign. But now it's showing you precisely where it thinks it's going wrong. It says district, well this is a key error, there's no district on this. So he's saying that, oh, manager, that still works, location, that works, that exists. But what about district? There's no district in here. So key error district. So if you just look at the extra squiggly lines here and look at the caret sign itself, it's giving you more precise messages. And this is probably helpful in let's say you have a big for loop, and in the big for loop you have a nested for loop, and then within that you have a ton of keys and stuff, let's say a very complex data structure up here. Then this could be this could be very useful. I can see it being situationally useful in terms of helping you debugging exactly line 16. Alright, cool, that's where you need to fix your code. So that's probably the most immediate improvement that most people come to realize when they switch to Python 3.11. But I want to talk about the next thing, which is self. So I have the same thing, the same employee is here, but now I've created a class, and then there's a former employee class. So 3.11 actually introduces a simple and intuitive way to annotate methods that return an instance of their own class. So for example, in this case here, I said create an employer class. So how I would use it is something like employer, and then I will have something like set website, and I'll set the website, right? This could be https supertype.ai. But when you call this method, it's just gonna bind the URL that you pass in here, and that's a string. It's just gonna bind that onto the website, but you really want to return its own instance. This should actually return an instance of employer. Okay. Now in the past, you may have tried to do something like employer and switch this to former employer like this, and then you try to save that. Then if you try to run it, let's say Python demo1.py. Okay, first of all, it says cannot import name self from typing because we actually have to comment that out now, because that doesn't exist in any earlier version prior to 3.11. So let's run that again. It says employer is not defined. So where did this employer comes from? It says here. employer. So it wouldn't scream at you just to say that, oh, employee is not defined, because this is where you actually define the class, and at this point it still haven't really exist yet. So already you're getting an error here, right? If you do it with Python 3.11, you see the same thing, but here it's saying that name employee is not defined, you mean employer. Now what we really want is to have this method being able, when you put an arrow sign like that, if you haven't seen this before, this is saying that what do you want to return. So for example, this is a print. So when I print, let's say I create something like em1 equals to employer, and I go ahead and print that, print em1. Now the print statement is going to be controlled by the representation function. If not, then it's the string function. So it's either this or it's the string. But the arrow sign here actually says that what do you want to return? What is the type of your return value? And in this case here, we're just returning a string, so we say that returns a string. If you say something like define, and we say number of employees, and let's say we return, well, we don't have that, but let's say we have number of employees somehow, and this is, let's say, a number, then we will return something like a numeric, like an integer or something, right? But in this case here, we're just returning a string, and here we want to return an instance of this class because that's what it's doing. And in here, it already complains that it says that name employee is not defined. Do you mean this? Did you mean that? And there's a lot of workaround, but they are a little bit hackerish. So 3.11 came about and said, well, all you need to do is to just say from typing import self, and you can fix this to self, and you can also fix this to self. And just to show you what the name equals to main is doing, it's saying that first, create an employer, set the website to supertype.ai, and then my previous work, I work at Gumi, and that's my former employer. So now I work at Algorithm and Supertype. But prior to that, I had another startup, but before that, I work at Gumi. Actually, before that, I had FunPlus, but before FunPlus was Gumi. And then it says, okay, take that and set website. Now, see what happened here is that when I create an employer, it's gonna call this method, and then it says set the website, but really return an instance of employer, and therefore I can actually have this as em1, and I can still do everything that I can do as an instance of this class. But what happened here with former employer dot set website? So former employer it inherits from employer, so it actually have the methods up here as well. So you have the representation and you have the set website as well, in addition to this, because it inherits from that. And when you call set website, it's going to return self, and this is the self. So self here is a type variable bound to the encapsulating class. So in this case here, if you return the type of em2, let's actually run this properly now. Let's run Python 3.11 and say demo1.py. You see that it's actually former employer and not employer because it's the encapsulating class, all right? So this is a lot more intuitive and more succinct, and it expresses the intention a lot better, a lot more clearer. Where prior to 3.11, if you try to hack around that, there could be problems with you trying to do this, and then when you do a type, you would actually see something like employer itself. If you try to, let's say, return this as employer, and then you say take this and return this as a former employer, and then you hack around that and you try to make it work, you may actually get this. And the problem with this is that you then don't get to set employment history. Why? Because that doesn't exist on the employer class. It only exists on the former employer class. So when the type of this is employer, this function will not work. So there's a lot of other problems with that approach, but now it's a lot better. You can just use self. If you go to their website and you look at this proposal that actually brings in the self type, if you look at analyze, search for that, it says here that, I find this interesting. It says we analyzed popular open source projects and found that patterns like the above were used about 40% as often as popular types such as dig or callable. For example, in TypeShot alone, such self-types are used 523 times compared to 1286 use of dig and 1314 uses of callable as of October 2021. This suggests that the self-type will be used quite often and users will benefit a lot from the simpler approach above. So I feel like this gives you an insight into how Python developers or the community itself, come about proposing new features and ideas, and they really make decisions in a very data-centric approach. They look at what open source projects, they see how often, they look at how likely is this to be useful to the general community, to the general Python users, and then they propose that. So I find that really interesting. Speaking of looking at the docs directly, one thing you can do is to go and just type in the PEP itself, and for example, another Python 11 feature, Python 3.11 feature, 0646. This is the Variadic Generics. This is a little bit too lengthy. I don't think I can fit it within, I try to keep the video short, so I don't think I can fit it in here, but I just want to maybe show you what it looks like. In the context of numerical computation with libraries such as NumPy and TensorFlow, the shape variable is often just as important. So for example, if you do this, this is not really useful or not really not as helpful as it can be, because it's not obvious what shape of array we should pass for the video's argument. So this array could look like this: batch times 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 height, width, and then channels, or it could be something like that. It could be completely different shape, but you only get to specify an array. So it's saying that the signature itself, this pattern itself, is not explicit enough. So then it proposed the type var. This is in the earlier one, and now in 3.11 it proposes type var tuple, and it allows you to do something like that. It says that you can go from typing import type var tuple, and from shape itself you can then unpack that, because it's a tuple. You can unpack that, and whatever you unpack, it's just gonna get into the array itself. So this is a lot more elegant, and you can use it to support, it says here, you can use it to support a number of different kinds of shape annotations, and there are a few examples here like that. You can say that, okay, the first one should be float, and the next one should be just a literal 480 and then 640, and you can read more about that. But I'm not gonna go into the example. I'm gonna just skip past this and just go into the next one. But that's another Python 3.11 feature. So let's go back and fix self, change this back to self, save that, and now let's go set out. Now demo2.py. Another feature of Python 3.11 is this introduction. This is a really short one. It provides support for parsing toml file in the standard library. So TOML, that's toml. At least that's how I pronounce it. So this is really simple. It just says, okay, I'm just gonna open a toml file, and I say with OpenSF. I can also additionally just say tomllib.load, but I would just rather print that out just to show you what it looks like. So in the prior version of Python, obviously this is not gonna work because this is not part of the standard library. So do that. It says cannot import. Oops, did I say demo.2.py? No module name tomllib, of course, because it's not part of the standard library yet. But in Python 3.11, it now goes ahead and print out the content of the file. So that's a really short one. Feature number 6 in demo3.py. So Python 3.11 also introduces a new variant of the try except group. So you see that there is now this asterisk symbol. So this asterisk symbol is how you work with something called an exception group. So this is exception, or rather exception groups, right? So for example, in this case here, it says try, and here's an exception group. And within the exception group itself, we just have to put one of the error, because otherwise we wouldn't see anything, unless you really want to write something that throw an error. But here we just sort of cheat our way a bit and just force an error, and the error will be blocking IO error. And it says that except. Now except here, this indicates that multiple exceptions. So for example, you see for example here, try raise one of these four, and then you said except, and this is a exception group, right? It says value type and error type, type error, value error, and type error. So if value error or type error, then go ahead and print this out and then print dash. But if it's a key error, then no such key. So that's one way to sort of group exceptions together. And it's something new to Python 3.11 as well. Just to show you how it looks like first, let's go ahead and run that, and let me compare to how the traditional try and except works compared to this new variant, right? So let me run that first. 3.11, I'm gonna say demo3.py. Okay, so let's take a look at this. It says here, blocking IO error. So this is raised, and because this is raised, it did not pass the try. So what happened is the except kicks in, and it first print REPR is kind of the string representation of the error group itself. And the error group is this exception group. So you see exception group problem, and then this. Then once it's done that, you see I also did a dash here, because I want to show you that you could also just print within this group itself. You can see there could be multiple exceptions. So for each of the exceptions, I want to print out the name. So in this case here, I'm only gonna see blocking IO error. But if I go ahead and change this list to include something like connection refuse error, OS error, interrupted error, blocking IO error, then I will see each one of those errors. So in a way, this represents a whole exception group itself. And so I name it EG, exception group. And you can print out each one of those and say, okay, if this is the case, if E equals to this, do what? If E equals to that, do something else. And you can do that in the kind of if-else block within the exception handling itself. In a traditional try except statement, there can only be one exception to handle. So the body of at most one except clause could execute. So the first one that matches the exception, that will execute. But the new syntax with this except, and then you put an asterisk sign here, this clause can match a subgroup of the exception group that was raised, while the remaining part is matched by the following one. So you can have another one. You said, well, if none of them, then try to match this. In this case here, it will never run because this will belong to that group, and so blocking our error would always be caught in here. But that's one way to illustrate this example up here. And in this example here, it says try, raise, except this. If it's one of these two, do something. If not, do something else. And in this case here, if it's a key error, this one gets printed. So we have the first two, validation, and so we have the value and the type up here. So these two gets to execute, but key error doesn't match any of this, right? So now this exception group gets to execute because it wasn't matched here. So this is the new variant of the try except, with the asterisk after accept. And of course, this will not work in the older versions of anything before 3.11. Try and do that, you would say invalid syntax, because what are you doing here, right? It doesn't understand that. Finally, for the 7th feature, let's go into demo 4.py. So let's take a look at what we have here. So we have the async. Here we're saying that nested is just going to print nested, nothing fancy here. And then define say after. And this is what it's going to do is that if you call say after, you want to pass it like that. So let me show you how you're going to use it. You're going to say something like say after, and you're going to pass it a second delay. So let's say 3 seconds of delay, and then hello or welcome. This will wait for 3 seconds. It would sleep for 3 seconds, but there's a wait, so it will be blocking. And then once the 3 seconds is done, you go ahead and print that. All right. And then this is the main function itself. We're going to call it main2 because there is another main down here. It starts off by printing the time because we want to make sure that all of this is working as we expect. And we're going to go ahead and say create 3 tasks. The first task 0, task 1, task 2. And then for each of those tasks, we're just going to await them. Why do you want to await them? Because if you just go ahead and just say something like nested, for example, if you do something like nested, this will not work. You want to use await nested. Okay, so if you don't have await, then this is really not going to do anything. If you go ahead and run that, you see that it actually does nothing. So nothing happens if you just call nested. A coroutine object is created but not awaited, so it won't run at all. So in this case here, I want to actually change that, and we want to use async IO and as a create task nested, and then we want to await for that. You can either do that or you can just maybe have await right there like this. But let's just keep it simple now. Don't want to complicate things. So we create the first task. That's just nested. Both the second task and the third task does something very similar. The first one is going to sleep for 1 second and then print hello, and you're going to await for that. Does the same thing, except it waits for 2 seconds instead of 1 second. So at the end of it, you print that. You expect that if you compare the start time and the end time, you'll see a difference of 2. Because the bottleneck is here, right? This is actually going to run, but task 2 is also going to run, except when it runs, it's going to come back in 2 seconds. So expect a deviation between the start time and the end time of 2 seconds. So let's see what happened here. So let's go ahead and say Python 3.11. Let's run demo 4.py. Let's save this. It says started 41, nested, hello, world, ended at 43. So that's exactly 2 seconds. So let's see what happens here. It says started. This is where it started. And then there's the nested, which is this. And of course you have the hello, and then you have the world. But because the row is going to have to wait for 2 seconds, so that adds from 41 to 43. So when you print the ended, you will see 41 plus 2 seconds as 43. So let's comment out this line, and now let's run the main function. Let's see the difference between that and this. So Python 3.11 introduces the concept of task group. So you can now say async io.taskgroup as a task group tg. So the syntax looks very similar still. It has the print statement, and then it has the print statement at the end. So just to see, how many seconds it elapsed between the start time and the end time. Then you have the try except block here. It says first, using a context manager, you have the with task group as tg. Tg stands for task group. Create task, sleep for 1 second, and then create a second task. If there is any kind of exception, then here we're using what we learned in demo 3, which is the exception group idea, and just log that. And so you want to bring in the logger as well. So we have the async io.log import logger, right? And it says, okay, there is something wrong here, so ignore all value error. You can also just do a print statement if you want to, but in the end, it just prints out the end time, all right? So then you say async.io run main. So you also want to make sure that you do this and not do something like that. This will also not run because this is a sync function. Calling this itself will not work. So what you want is to have something like async io.run and a main. So I have a note here that says that simply calling a coroutine will not schedule it to be executed. This will not work. To actually run a coroutine, you need to call async io.run or to use await. So you can just do this, or you can just call await main. Let's say if this is nested in another level, you can just call await for main. But in this case here, we just say async io.run main. All right. So let's save that, and let's see what happens now. Let's run that. So it says 38 and then 41. Now there are 3 seconds between 38 and 41. So what's happening here? Now what's happening is that even though this is asynchronous, there is the await in here. So the await here actually holds for 1 second before this even gets to run, because you are waiting for that, right? So if you take that out, or actually let's just comment that because we may want to come back to it later. So let's just comment that out. Now it would just be 2 seconds. So 16 and then hello and then 18, right? Because this async io, this is not going to stop the process. This is not going to wait for the process now. So it's just going to run 2 seconds. So this is the same as the one above there. But what's really cool about task group is that it now introduces a way to group this into a set of nested tasks. So if one of them fail, all the other tasks that are still running would be cancelled. So for example, let me just change this to something that doesn't make sense. If you look at say after, it needs a delay and it needs to run sleep and then put in a delay here. But let's run something nonsensical. Let's put in a value like x, y, z, and let's save that. Let's run it. Oh, now it's not running. Let's see it. Let's see that again. Whoops, it's not running. It's saying that if delay is lesser or equal to 0, but then it can't even do this comparison. Why can't it do that comparison? Because this is actually a string. It's not even a number. It can't actually do the comparison between an instance of string and an instance of integer. Now you have the exception group being kicked in. This is what we learned in the earlier demo, and it says here that unhandled error in the task group 1 sub exception. And sure enough, if one task failed, all other tasks that are still running would be cancelled. So this could be some long running tasks here, but they will all be cancelled if one of those tasks fail. This task group here also allows you to execute code while between scheduling nested tasks. So you can also, including running await statements, you can also have another await statement doing some other stuff here. You can do some other stuff in here. And thanks to the exception group here, all errors are propagated and they can be handled and they can be reported. So let's change this back to maybe 1 second again. So now we should expect 2 seconds plus 1 second. So in total 3 seconds. Let's run that again. And now it should work. Right, 57, we should expect 0, 0. And there we go. Just as a bonus, if you want to try out Python 3.11 and you're on a Linux machine, you can go ahead and install that. And I'll show you really quickly how to do that. And I'm sure you can Google up instructions for how to do that on Windows or on Mac OS, but I'm using Linux, so I'm going to show you how to do that on Linux. So I'm going to say, first of all, you want to make sure that all existing packages are updated. So first thing you want to make sure is you just do something like this, update, and just say, and sudo app upgrade -y. -y just say yes to everything, so you don't have to keep confirming and press yes. So this first step is going to make sure that all existing packages are up to date. Took me 30 seconds to have all the packages upgraded, but now you need to add custom PPAs, and the prerequisite for that is called software properties common. So let's also install that. Let's do something like sudo app install software properties common -y, and this will just install that. I'm not going to do that because it's just going to waste your time, but this is really just a prerequisite for adding your PPA itself. So let's go ahead and just add the PPA directly. So let's just do sudo app apt repository, and then you put datesnakes /ppa-y. And once you're done with that, you want to just do a sudo app update again. This is the same command as what you did earlier, but here it just refresh your apt sources just so it to include the datesnakes PPA that you added. So sudo app update just kind of refresh that sources list itself, and now you can go ahead and say sudo app install, and you can say Python 3.11, and that's about it. Then if you want to confirm that all of this is done correctly, just say Python 3.11. You can say version, and that will just print out that version, or you can just write which Python 3.11 and it will show you where it is. And this is probably going to be helpful if your Visual Studio Code did not immediately pick that up. So what I do is I just have to Ctrl-Shift-P, and then I say select interpreter, and then from here just type the full path in there. So click on that, enter interpreter path. It says enter path to a Python interpreter, and this is where you enter that user bean Python 3.11. I've already done that already, so now it finds it. But the first time we install it, either you restart Visual Studio Code or that you can just do it this way, and either way you should pick that up and you can go ahead and experiment Python 3.11. And that's it for the short video. I wish you the best of luck in your Python journey.